Hello everyone and welcome to the third lesson in our Mega Drive Genesis beginners tutorial series. In the first two lessons we learnt how to put backgrounds on the screen and also how to scroll those backgrounds in parallax scrolling, so I'm sure a lot of you are now very keen in getting on with creating your own backgrounds, and that's exactly what we're going to do today. Now there are a ton of pixel art tutorials on YouTube by artists much better than me. If you've seen my GG Shinobi art, you know that I'm just a beginner at this, so I'm not going to spend too much time on the actual art creation and advise you on that. What I'm going to be focusing on in this video is something that I can help with, which I don't think is on YouTube at the moment, and that's how to make graphics specific to the Mega Drive, so ones that take into account the hardware limitations and also to talk about what kind of format they need to be in order to be accepted by the SGDK system. I'm going to be using a pixel art drawing software called Aseprite. You can buy it on Steam, but feel free to use whichever software you're most comfortable with. I'm sure so long as it's all in the same format that it should export okay to the Mega Drive. Let's begin with a very practical example, and then as we go along I'll gradually introduce the more technical aspects. Welcome to Aseprite everyone. So what we're going to do now, we're going to go File New and create a new graphic. We are going to be focusing on backgrounds today, so in terms of doing the width and the height, remember if you want to do parallax scrolling without any gaps for a basic background, it needs to be 512 pixels wide by 256 pixels tall, but for now we're going to keep things very simple. We're just going to fill a whole screen with a background, so one screen will be 320 pixels by 224. Next we're being given a choice of color mode, so you have RGB, you have grayscale, and you'll also have indexed. Now index is going to come important later, we're going to use it, but for now just choose RGB. And next up we also can choose transparent or white or black. Transparent we're going to come to again later, but for now just choose white. And now we have our 320 by 224 screen. One of the most important aspects in doing graphics for any retro system, the Mega Drive included, are the palettes. So if you click on presets, you can see the Aseprite includes lots of already preset palettes for various different older consoles. So you have the Atari 2600, the Commodore 64, and also for example the Game Boy, and also the Game Boy Color and the Master System too. If we open up the Master System one, you'll see that actually it doesn't have too many colors, but I think the palette is quite nice, has a nice pastel-y feel to it, and if you look at some Master System games, the developers and the artists really made good use of the colors it did have. However, curiously enough, one of the systems it doesn't have the palette for is the Mega Drive. So what we're going to do is we're going to have to import our own. Now I have a download link for you so you can download it. I think I've found this palette on a forum somewhere. I can't remember who did it, but it seems to be very accurate to how the Mega Drive really is and really works. Feel free to adjust this window here to get it as you like to have it, and so you can make it bigger vertically or bigger horizontally, and as we move along you'll see that the colors almost kind of snap into place. It's quite interesting to look at really. As I already said previously, I'm not going to go too deep into how to use Aseprite itself because there's lots of really great tutorials online already, so I'm just using the mouse wheel to zoom in and out. But what I'm going to do is to add this grid. So we want to add a grid of 8 by 8 pixels because that's how the tiles are going to work on the Mega Drive, so I think it's very useful to always add this grid whenever you're doing Mega Drive graphics. If you press H on the keyboard you can bring up this little hand. You've also got the options on the right, and then you can move the screen about as well, and if you press B you bring up the brush and you can change how large the brush is, how thick it is, whether it's by 1 pixel or by 4 pixels, 5 pixels, etc. And now I'm just going to click Ctrl Z just to undo, so Ctrl Z to undo, Ctrl Y to redo, and you have lots of these options so you can choose whichever color you want, and you can choose the different types of brushes and tools. We're going to keep things very simple here. One, because I'm not a great artist and there are a lot better tutorials online already, and two, just to keep the video relatively short. I don't want this to drag on for too long. I think for this background we're going to do a very kind of simple sky and maybe a bit of ground, so let's make this a nice Sega blue sky. And in case you're wondering, that paint bucket tool that fills in a certain section with a single color, you can just press the G button and that's a shortcut and you can just fill it in. Before I continue on, I want to show you, you could call it a little trick I suppose, for how I keep track of how many colors I'm using, because remember the Mega Drive, they have 64 on-screen colors and they're divided into 4 different palettes of 16. So for this single background we're going to be limited to 16 colors. I'll talk more about the palette system later on, but I just like to create an extra row of tiles on the right hand side, and then I use this to keep track of what colors I'm using. So here I'm just filling in 1 tile's worth with the blue color we just used, and when I add more colors I'm going to add more to this column here, just so I make sure I'm not going over this 16 limit. Now today we're doing something very simple, so that's not going to happen, but when you're drawing a proper graphic it's very easy to lose track of which colors you're using and how many colors you're using, because you don't want to go over the 16 color limit. Now a sky wouldn't be a sky without some nice clouds, so I'm going to draw some very simple clouds. It almost looks like an Atari 2600 game rather than a Mega Drive game, but as I said, for this tutorial I'm keeping it simple. The focus is on the formatting and the limitations and the basic technique, and not on the art itself. To use this cut and paste, or rather copy and paste tool, you can just push the M button, then drag it over, then Control C, Control V, just like you'll do with any kind of cut and paste. Now before I forget, I should probably add the white to that little column on the right hand side that is keeping track of our colors. As I said today, it doesn't matter too much, but it's a good habit to get into. And now to finish off this masterpiece of 16-bit graphical design, let's draw a little floor. So let's go for a nice basic green color to a nice grassy floor to go with the Sega blue sky. And now just add the green to our little column on the right hand side as usual. Okay, so I think everyone would agree that that looks absolutely amazing and is a suitable background for any Sonic 4 Mega Drive game. Now if we just push the C button again, then we will come to this. We can adjust the size of the screen, and we don't need that right column anymore, so we've kept track, so we don't need that to be in our graphics on the actual game. What we need to do now is to get rid of all the excess colors, so we want to only have the colors that we're going to put into our game. So just then I selected the new palette from Sprite option, and as soon as I click OK there, you see this got rid of everything except for the 3 colors we're actually using. So at this stage, if you notice there are 17, 18, 19 colors, then you've obviously done something wrong and you need to reduce the colors. And last of all, before we save, we have to go to Sprite Color Mode and then select Index. So if you recall before, when we first opened the file, it asked whether we wanted RGB color indexed. I'd explain why we selected RGB color first and then chose index after, but for now just change it to index now. And we are now ready to save the file. You can call the file whatever you like, but the most important thing is the file type. So we need to save this as a PNG file. And now we return to the code we wrote in the previous lesson on parallax scrolling. So I've commented out most of the code to do with the scrolling and the second background and so on. I've left the 2 variables in because it doesn't matter whether they're in or not, they're not going to affect anything. And all we need to do now is go over to the resources.res file and simply change the background we used in that lesson with our new background. And as always, don't forget to hit the save button as soon as you make any changes, and now we'll compile and open the emulator. And there we have it, our masterpiece on the Mega Drive. Now that we've done the background, let's now draw the foreground, which will be slightly different. So again, the width is 320, height 224, and RGB again, but this time we're going to choose the transparent background. While we're here, I'm going to show you how to make the Mega Drive palette the default palette. So every time you open a new file in Aseprite, it will automatically put that palette, so you don't have to keep loading it every time you open a new file. So let me first navigate to the Mega Drive palette, and this time we're going to click on here again, and we're going to choose the Save Palette as Default option. Okay, now let's get on with drawing our foreground. So I chose the transparent color that Aseprite gives you. Actually, the color can be any color you want for the transparent one. Whichever is the first color in that palette is going to be ignored by the system. So it could be pink or green or anything. If it's the very first color in the palette, it won't come up anyway. But I just like to use the transparent one that Aseprite gives you. Now, each of these squares is actually 16 by 16 pixels, and if you want you can change it to 8 by 8, but I just like to do the grid over the top of it anyway, just like we did with the first one, but it's up to you how you do it. For this foreground, I think I'm just going to choose a brown color and we're going to draw some trees. And just like before, these are going to be Atari 2600 quality graphics here, so the tree is going to be very simple, and maybe just to make it a bit different from the grass, I'll make the leaves are kind of a blue color instead. I'm not going to waste too much time on this, so next I'm just going to simply push the M button and then copy and paste the tree, so we've got 2 trees for the foreground. Yet another beautiful 16-bit Mega Drive graphic, I'm sure you'd all agree, and all we have left to do now is what we did last time. So we're going to select new palette from Sprite, and as soon as we click that, you can see we have the first one in the index, which is going to be ignored anyway. It doesn't matter what color it is, it's just going to be see-through so we can see the background. And we have the other 2 colors, and then we're going to do the sprite color mode and select indexed. Finally, we're going to save as, and just like before, we need to save it as a PNG file. And just as before, we're going to return to our little program, and we're going to replace the old foreground with our new foreground. This time we're going to need to make some changes to the main file, so we want to uncomment out these, so we can just select all of the rows and we can just do Control and / and it will comment and recomment them out. So that's a little shortcut for you. We don't need any scrolling just now, so we can get rid of that. And finally, what we can do now is we can save and compile. Remember to save both files, both the resources.res and the main.c. And we have a bit of a problem. So remember last time we were messing about with the position of the background. So -4 rose it up for 4 tiles. If we do it normally, then now this is due to the way I've drawn it. So I've drawn it a bit too high, the trees. If we push it down 4 tiles, then maybe it'll just about fit. So if we save and recompile, and I think that's good enough. So it probably could have been moved up 1 tile, but I think that's good enough for now. And just to test things out, why not we'll get rid of the comments on the scrolling code. So we can do a little bit of parallax scrolling and just see how it looks. I'm sure it's not going to look too special, it's not going to look too great, but just to make sure that the code we wrote before is all working okay. And there we have it, we have some parallax scrolling. Now, just as in the parallax scrolling lesson when we did the 320 by 224 background, that's not big enough, so you're going to have this green space here in between. If you wanted to have the proper parallax scrolling, you need to have the bigger background like we did before, the 5112 by 256, but for our purposes now, that's absolutely fine, so it's all working okay. Now that we've gone through a couple of practical examples of how to create graphics and how to import them into SGDK for display on your Mega Drive, let's talk a little bit about the hardware limitations and the colors and so on. No matter if you're drawing backgrounds or sprites, which we'll be doing in another lesson in the future, remember that the Mega Drive, it stores graphics in the VRAM and it puts them onto the screen as 8 by 8 tiles. So any graphic you draw has to be a multiple of 8. So it has to be 8 or 16 or 24 or 32 and so on. It can't be, for example, 17 long or 17 high. It has to be a multiple of 8. If you don't do that, then you're going to get this kind of error. I talked a bit about when before we saved we had to choose index as the color mode. Now you can think of how the Mega Drive handles color, this index color mode, similar to these coloring books you get where it gives you a number. Whenever you see that number you have to draw a certain color. The Mega Drive numbers the colors in its palette, its on-screen palette, from 0 to 63, so 64 in total. And just like the coloring book, wherever it sees a certain number, it's going to put a certain color. So you have to tell the system which colors go to which number. We can actually see that in action by using one of the backgrounds we did before. So if we choose the RGB color, if we then try to swap the colors around, then it doesn't make any difference because RGB color doesn't work like that. But if we change the color mode to index, now if we swap the blue and the white around, we'll see what happens. You can see that they've swapped, it's an index, it's like the coloring book. So if we change the green and the blue around, what was green is blue and what was blue is now green. So that's how it works with the index colors. So we can keep swapping them around. So it's wherever it sees that number, it says, okay, at this number, put this color. So just like the coloring book. Many games actually use this feature to have these pseudo animations. So you can see on the Streets of Rage logo, and when we start the game, it uses palette cycling to change the colors and make it look like there's some kind of animation going on. So in the Rage part of the Streets of Rage in the intro, and also here with the street sign, so it makes them look very active, but it's actually just the colors cycling through, as you can see from the fourth palette at the bottom right hand side of the screen there. In future, I might do more videos where I analyze different Mega Drive commercial games and just see what little tricks they use, because I think it's quite interesting. It's quite a useful learning experience for those of us who want to make our own games. Another important thing to note about palettes is you may have noticed over the past 2 lessons when we've been using this VDP Draw ImageX function of SGDK to display a background layer on the screen, we've been allocating a single palette to the entire background layer and also a single priority, whether it's high or low priority, true or false to the single background layer. Now this isn't actually how the Mega Drive works. The Mega Drive is more flexible. It can determine the palette, it can allocate palettes by tile, not necessarily the whole entire background, which means you can use multiple different palettes within the same background layer, and you can have different priorities for different tiles as well, which is much better for our game development. Anyone who watched my recent Castlevania video might remember I spoke about a new tool which is going to be compatible with SGDK, and this makes it much easier. So we can have it works like the Mega Drive does. We can have a single background layer, but we can allocate palette 0, 1, 2 or 3. So we can have potentially all 4 palettes within the same background layer. So please keep in mind that the way we did backgrounds today, we worked within the limitations of SGDK rather than the Mega Drive itself. But as soon as this tool is ready, and it should be ready some point this year, I'll have a tutorial on this for sure, because we can do so many useful things for it. It's going to be so great for level creation, for assigning priorities, and for the color use and everything else. It's just going to be so much user friendly, and I'm really looking forward to using it, and I'm looking forward to teaching everyone else how to use it as well. One thing we haven't talked about yet is the VRAM. So the VRAM is how the video RAM, how many tiles can be stored by the Mega Drive video processor. Now it's not as limited as say the NES or the Master System, and I believe it's correct that you could technically get a single background layer full of unique tiles, and I think the VRAM will be able to handle that. But don't forget, we have to have a second background layer and sprites and so on, so it's always a good idea to have lots of duplicate tiles. Now the Mega Drive is quite clever. It duplicates tiles by, as you're seeing here, the screen at the moment, we have these tiles which actually is just one white tile and one with this red in the corner, but the one with the red in the corner, it can be flipped vertically and horizontally, so it can only count as one tile rather than 4 separate tiles. And fortunately for us, the SGDK does that automatically. We don't have to tell the SGDK that we're doing this or do it manually. When we upload this kind of image into SGDK, it would see which ones can be mirrored vertically and horizontally, and it will save the space for us. Fortunately, the Gens emulator we've been using has a pretty neat debug feature where we can look at the state of the VRAM, and just ignore these first few tiles. They're actually the color RAM, so they're the color palettes, but the final 2, you see there's a white tile and there's a little bump, and that's how single tiles. So it's only loaded one of these tiles in the VRAM, and the rest of it is just flipped it horizontally and vertically, so we've saved all that space. Before I go into a recap of everything we've learned today, I just want to address the issue of why we started off at RGB color and then switched to index. So we're in RGB color at the moment, color mode. and you can see everything's fine. We can choose whichever palette color we like, and it's all as we expect it to be. But if we change to index at this point, you see something strange happen, is that the colors have changed. The white's gone to yellow, and if I choose the colors from the upper half of the palette, everything seems fine as usual, is the colors are exactly as they are in the palette. But if I go to the bottom half of the palette, it's not as expected. The blue's like a purple, the pinks are red. This blue here is more of a very dark kind of mauve. This light blue is a green color, and this what should be white is yellow. So what's going on here? Well, I believe that for index modes, the maximum number of colors is 256. So once it gets halfway down the palette to 512, it starts to repeat colors or to mess them up. So that's why we start off in RGB mode if we're using the full 512 color palette. Then you select which colors you want, and then you select the number of colors, the 16 colors in your background, and then you switch to index modes, and then you don't have this kind of messing up of the colors. If anyone watched my earlier Castlevania videos, especially the entrance ones, you may notice that there was a certain yellowy tinge to a lot of the castle walls, and that probably should have been a white, but I didn't realize it at the time, the mistake I was making. And once it did get to this yellow color, I actually quite liked it. It's almost like a yellowed paper, like in an old book you get, so it made the castle look kind of old, so I kind of kept it. But it was actually a mistake that gave it that special color, and I just didn't realize at the time. It's only afterwards that I finally realized what was going on. So just to have a recap before we go, if you want to create graphics for the Mega Drive, first you have to make sure that the size is correct, the dimensions, so both the height and the width has to be a multiple of 8. And also we need to make sure that it abides by the palette's limitations. So especially with the way we're using SGDK at the moment to do the backgrounds, or when we do sprites in a future lesson, we need to limit it to 16 colors. And also for the color mode, it needs to be index color mode before we save it. And when we do save it, we need to save it as a PNG file. And last but not least, especially when it comes to backgrounds, you probably want to have quite a few repeated tiles. You want to create like a tile set, because although the VRAM is pretty, it's not so bad for a 16-bit system. I mean, it's handling Castlevania Symphony of Night, lots of the backgrounds there without too many changes. It's always a good idea to have lots of repeated backgrounds just to save on VRAM memory. But the SGDK, if you want to create lots of mirror tiles and so on, it will detect that automatically, so you don't have to do any manual work there. But it's always good to have a tile set, and then from that tile set you build your level graphics from there. I think after hearing about all the various caveats and limitations to the hardware to doing graphics on the Mega Drive, I think especially for those of you maybe who are already artists at the moment, you're already very good at drawing and painting, and maybe if you've done pixel art before, you probably have a better idea of whether creating Mega Drive Genesis graphics is for you or not. So it all depends on your attitude to these limitations. I think for me, especially the importance of handling the palettes, so we have these 4 palettes of 16, and how you share those across the screen, which ones you allocate to which enemies and characters and which background tiles and so on, really determines how good your graphics are going to be. Is a very vital component of it. And for me, it almost has a puzzle element. It adds a puzzle element to the whole process, which I find very interesting and very fascinating. And obviously, you know that Pyron, the pixel artist on Castlevania Symphony of the Night project, he's an expert at this, and there are lots of other talented people in the field too. So I really hope that this video has encouraged other people to get into making Mega Drive graphics, because after all, doing graphics is a vital part of any game. And even if you're not super into the rest of the programming aspects of the whole game creation, even just doing the first 2 lessons of this tutorial series plus this lesson here, you probably have enough knowledge now of programming and knowledge of how the art works to create your own graphics and to put them on the Mega Drive and try them out, and you'll no doubt be an asset to anyone making a game to create these beautiful graphics. I think with the Castlevania project, not necessarily the graphics you're seeing on screen here, because this was a very early build that I did personally, but especially with Pyron's later graphics, you can see how much potential the Mega Drive has. It's not really a technical feat, it's more of an artistic feat. So how good the graphics are, it's not just about the technical aspect, it's also about the artistic aspect. So I think we can get some really good graphics on the system with future games. There's already been lots of great games in the past that had great graphics, and I think with all these new homebrew and indie titles, we can really up the ante and really create some beautiful looking games. That's it for this lesson. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
Farewell.